Good evening, everyone. So in the last class, we discussed about the oblique projectile, and we also discussed some of the questions related to oblique projectile. And in this lecture today, we'll be discussing about the horizontal projectile, right? We'll be calculating all the physical quantities as it is that we discussed or calculated in case of oblique projectile. But now the same things will be done for the horizontal projectile as well, right? So horizontal projectile by horizontal projectile we mean that let's suppose we are projecting this is the top of a tower, right? This is the top of a tower, and from this top of the tower by projecting a projectile like this, we're projecting a projectile. So this is how this projectile is going to be, right? We call this projectile as horizontal projectile because we have projected this projectile in a horizontal direction, right? With some initial speed, right? Along horizontal direction. It means that initially at time t equal to 0, the angle at which it is projected with respect to horizontal, it's 0 degree, right? It's parallel to the horizontal at time t equal to 0. And this projectile we call as horizontal projectile, right? Let's suppose this projectile has been projected from a height h, and this projectile strikes here at some point P on the surface, at some point P on the surface. And once again, we have to find all the parameters for this projectile as well. We have to find the time of flight for this projectile, time of flight, and we'll be then discussing about the range of this projectile, right? Range. Then we'll discuss about the velocity at any instant, right? And then finally, we'll discuss about the trajectory of this projectile, right? Trajectory of this projectile, and then we'll be discussing some of the questions related to this projectile motion, right? And here we know that for this horizontal projectile, the initial vertical component of the velocity is 0, so we can say that uy is equal to 0 and ux is equal to u, right? And the x component of this projectile is once again going to be a constant because there is no acceleration along x direction. We can say that ux is going to be a constant, right? Ux is going to be a constant, correct? So if we calculate vertical velocity, vertical component of the velocity at any instant, that will be given by uy plus uy minus gt, right? Uy minus gt. So at any time, the vertical component of the velocity will be minus gt. It means it will be vertically downwards, right? So it means, let's suppose at any instant the particle is at this point, and let's suppose the velocity will be in this direction, that's tangential to the trajectory, right? And there will be one component which will be in the horizontal direction and another component will be in the vertical direction. We call this as vx component and this will be vy component, right? Let's suppose this is the theta at any instant, then this tan of theta is going to be equal to Vy upon Vx, right? Vy upon Vx, correct? So theta is the angle with horizontal at any time of instant. That will be given by the vertical component of the velocity at that instant divided by the horizontal component of the velocity at that particular instant. So let's try to calculate the time of flight for this projectile motion, right? Time of flight for this projectile motion. And let's suppose we are doing all the measurements are done with respect to the reference, right? If all the measurements here are done with respect to the reference, let's take this as reference. Top of the tower is taken as the reference, right? This is the reference point, right? So this is our reference, right? So with respect to this, we'll be calculating all our variables, right? So this is our x-axis, this is our y-axis. So this is the reference point, right? It means the distance measured below the y-axis will be taken as negative, and the distance measured above the y-axis will be taken as positive, and right hand side will be taken as positive, and the left hand side will also be taken as negative, right? So let's try to calculate the time of flight, right? So time of flight is the time it takes to strike the ground at point P, right? We know that we can use this equation y is equal to u by t plus half a by t square, right? A by t square. And initially there is no horizontal component, there is no vertical component of the velocity, right? Because the total velocity at time t equal to 0 is totally horizontal, or we can say uy is equal to 0, right? So uy is equal to 0. So from here y is equal to half a by t square, half a by t square. Our ay is nothing, that's equal to minus g because it's vertically downwards. We said that by reference, we all the measurements done below the y-axis, below the origin will be taken as negative, and all the measurements done above the origin will be taken as positive, right? So ay will be minus g here. So we can see this y here is measured from this reference, and this y has to be equal to negative when this particle strikes point P. We can say that this y is nothing, it's equal to minus h. Why did we take it minus h? Because the reference has been taken on the top of the tower, and the distance is measured below this origin will be taken as negative. So h is below the horizon, below the horizontal line, so it will be taken as negative, right? So it depends upon the reference, right? So we have chosen a reference to be at top of the tower. So that's why we're taking y is equal to minus h. We can substitute the value of y and a in these equations. So y is minus h. That will be equal to minus half gt square, right? Minus half gt square. And the time till it strikes back will be the capital T. That's the time of flight. So it means this minus and minus will get cancelled. So from here, we can conclude that our time of flight will be nothing. It will be under root of 2h over g, right? So under root of 2h over g. So we can say that time of flight is nothing, t, that's equal to under root of 2h over g. So this time of flight will only depend upon the height from which it has been projected, right? It will only depend upon the height from which it has been projected, right? So we can say that this time of flight is proportional to root of h here, right? Under root of h, correct? So that's the time of flight, right? That's the time of flight. So this is the time after which it is going to strike back on the ground, right? And talking about the range of this projectile, range once again is the maximum horizontal distance traveled by this projectile, right? And the range, it's the horizontal distance. It means that it will only depend upon the horizontal component of the velocity and the total time for which the uh, particle has traveled throughout the motion, right? So the total time is the time of flight, and the horizontal component of the velocity is initially given as u, right? It was projected at an angle of 0 degree with the horizontal with speed u. So multiplied by t, where t is the time of flight. So we can write it as u under root of 2h upon g. That is nothing, it's going to be the range of projectile, right? Range of projectile. So this is nothing. R is going to be equal to horizontal speed and the time it has been traveling till it strikes back on the ground. That's our range of a projectile, right? So this is the range of a projectile. So we calculate time of flight, we calculate the range of this projectile. And now we have to calculate the velocity at any instant, right? Velocity at any instant for this projectile. For this projectile, velocity at any instant. Uh, let's see that this is the projectile here, right? And this has been projected in this direction like this. Like this. This is how the projectile moves, right? And at any instant, this is the velocity here. Velocity here. Let's call this velocity as v. And there will be two components of the velocity. One will be vx, another will be vy. So this is vx and this is vy. And this v vector is nothing, that's equal to vx I cap, right, plus vy j cap, right? Or we can write the magnitude of this projectile, magnitude of this velocity as under root of vx square plus vy square, right? And vx is a constant, right? That's equal to u. And we can see that vy is nothing, it's equal to minus gt, right? From here, the v or mod of v will be nothing, that will be equal to under root of the u square plus g square t square, right? So this will be the velocity of this projectile at any time t, at any later time t, right? So this is the magnitude of this velocity, right? And the angle, if we have to calculate, suppose this is the theta at any time, the angle theta with the horizontal will be, that will be tan of theta, it will be equal to Vy upon Vx. And Vy is nothing, it's Gt, right? Gt upon x, that's equal to u, right? So this will be the theta here, right? This will give the magnitude of the angle which it makes with the horizontal after some time t, right? After some time t. So we calculate the time of flight for this projectile, we calculate the range of this projectile and velocity also. Let's move on to the next thing that we have to calculate. We have to calculate the trajectory of this projectile, right? Trajectory, right? Trajectory of projectile. So we know the trajectory of this projectile is parabolic trajectory, right? But we have to just derive the relation, what kind of parabola it is, and what is the trajectory, actual trajectory, equation of trajectory, right? So this is the projectile, how it follows the path, right? And we have to establish a relation between the x coordinate and the y coordinate for this projectile. That's what we mean by the trajectory for projectile, right? And we know that x coordinate at any time will be nothing. It will be initial speed multiplied by t because there is no acceleration. So uh, that's why we are not writing the acceleration term here. So it's x is equal to ut, right? And similarly, y is going to be equal to minus half gt square, right? Minus half gt square, correct? Minus half gt square. So we can substitute the value of t as x upon u. If we put the value of t in this y as x upon u, so it will be minus half g t square t, so it will be x square upon u square. So the value of y is going to be equal to minus gx square upon 2u square, right? So this is nothing, this is the equation of trajectory for this projectile, right? This is the equation of trajectory, right? Equation of trajectory for this projectile. So this is the equation of trajectory for this projectile. We can see that the equation here is, it's a negative, coefficient is negative for x square. We can say that if the coefficient of x square is negative, then it's always going to be a downward parabola, right? So it's once again a downward parabola. So it is concave downwards, or we can say it's downward parabola, right? So once again, this represents the equation of trajectory for this projectile, that is y is equal to minus, let's suppose ax square, where a is nothing, a is equal to minus g upon 2u square. So this is the equation of trajectory for this projectile, or the projectile motion, horizontal projectile motion, right? So let's move on to the next things, rest of the things for this projectile motion. We'll just try to solve some of the questions related to this projectile, right? The question number one here is a ground to ground projectile, right? It's the projectile related to projectile motion related to ground projectile, right? It means that this question is for a oblique projectile like this. For an oblique projectile, this is our oblique projectile like this, correct? So it has been projected at an angle of theta here, right? At an angle of theta. So let's suppose it was some projected with some initial velocity u here, but here a ground to ground projectile has equation of trajectory given as, the equation of trajectory for this projectile is given as x minus x square upon 40, right? X square upon x minus x square upon 40. Find angle of projection and speed of projection, right? We have to find the angle it has been projected and the speed with which it has been projected, right? If you remember in the last lecture, in the previous slides, the equation of trajectory that we calculated, for the oblique projectile, it was equal to y is equal to x tan theta. It was equal to minus gx square upon 2u square cos square theta, right? Minus gx square upon 2u square cos square theta, right? I think this was the equation of trajectory. You can just confirm it. Here x was equal to u cos theta t, right? Cos theta t, and y was equal to u sin theta t minus half gt square, right? Okay, so t was nothing, it's t was x upon u, right? So it has to be t will be equal to x upon u cos theta. It will be x square upon u square cos square theta. That's twice, right? So this is the correct equation, right? It means that this is the correct equation for the equation of trajectory, right? So this is the equation of trajectory, right, for this oblique projectile. Now we can compare the two equations. We can see here the tan of theta is nothing, that's equal to 1, because the coefficient here is 1, so the tan of theta has to be equal to 1, and from here we can say that theta is equal to 45 degree, right? And similarly, if we compare the coefficients of x square with the coefficients of the equation of trajectory, so it means that our g upon 2u square cos square theta has to be equal to 1 upon 40, right? It has to be equal to 1 upon 40, correct? That's equal to 1 upon 40. So we can replace g with 10. It will be 2u square, and cos square 45 will be equal to 1 over 2, right? This 2 and 2 will get cancelled. We'll be left with here 1 upon 40, right? So from here, u square will be equal to 400, or we can say that our u is nothing, that's equal to 20 meter per second, right? 20 meter per second. So this is what we call as the initial speed with which it has been initially projected, right? So this is how it has been projected initially. We can calculate this angle using a different method also. We can use the differentiation concept of differentiation here also to calculate the angle at which this projectile has been projected, right? We calculated the angle here by comparing the two equation with the equation of trajectory of this projectile, but we can also calculate this angle by using the concept of differentiation, right? Or using the concept of derivatives, right? We know that has been given as x minus x square upon 40, right? And we know that dy by dx, what does it represent? It represents a slope at any point, right? And that slope is also given by the tan of theta, right? If we differentiate this, that will be 1 minus 2x upon 40, right? But that's equal to minus 1 minus 2x upon 1 minus 2x upon 40, right? So this is the what we call a slope, right? And the question is that it's asking us to calculate the angle of projection, means the angle at which the particle was projected. And when this particle was projected, it was at origin. It means that the coordinates of this particle at origin has to be 0, 0. It means that at origin, at which when it was projected, the x coordinate would have been 0. Just put the x value here 0, right? If we just put the value of x here 0, it means that we get tan of theta equal to 1. It means that so theta is equal to 45 degree once again. So there are two ways of solving this projectile, right? We can also calculate other things for this projectile as well. Let's suppose for this projectile we have to calculate the maximum height. We have to calculate the range of this projectile. Then how will we proceed to calculate the maximum height and range of this projectile? One is if we calculate the range, if we calculate the velocity and angular projection by comparing the equations of trajectories, we'll be able to find the range as well. But another way is to use the concept of the differentiation, right? We can find the concept of we can find the range of this projectile using this equation only directly, right? It means that y has been given as x minus x square upon 40, right? So y is the vertical or y coordinate of this projectile at some time t, right? X is the x coordinate. Once this projectile motion strikes this horizontal level, it has some x coordinate, right? But its y coordinate is equal to 0, right? So it means that its y coordinate will be equal to 0 So at that time, the value of x will be equal to will be equal to range of this projectile, right? When this particle strikes the oblique horizontal surface, when this projectile strikes the horizontal surface, its y coordinate will be equal to 0 and x coordinate will give us the range of this projectile. If we put the value of x here equal to y equal to 0, right? Y equal to 0. It means x minus x square upon 40 will be equal to 0, right? It means that x into 1 minus x upon 40 will be equal to 0. It means that this equation has two solutions. One solution is x equal to 0. Another solution is solution is x equal to 40, right? And x equal to 0 is the point where the particle was projected. That's the origin, right? That's the origin. And x is equal to 40 is this point, right? This point P where it strikes. So it means that range of this projectile is nothing that's equal to 40. So 40 is the range of this projectile, right? 40 is the range of this projectile. If we calculate the maximum height for the same projectile using the concept of the differentiation, right? Using the concept of this differentiation, right? We know at at maximum height, this is the maximum height, right? At maximum height, the slope of this horizontal line is equal to 0, right? Slope is equal to 0. It means that at maximum height, dy by dx has to be equal to 0, right? It means that if we differentiate this, it will be 1 minus 2x upon 40. It has to be equal to 0, right? It has to be equal to 0. If this is equal to 0, it means that value of x at which it will be 0 will be equal to 20, right? That will be equal to 20. The value of x at which it is equal to 20, it is slope is equal to 0, that's equal to 20. If we substitute the value of x in this above equation, we will get the value of y, which is the maximum height, right? So h max will be equal to 20 minus 20 square upon 40, right? That is equal to 20 minus 400 over 40, right? So it will be 20 minus 10. So h max will be equal to 10 meters. It means the maximum height for this projectile is nothing. It's actually h equal to 10 meters, right? So I showed two methods or two ways to solve this projectile. One method was the comparing this equation of trajectory with the trajectory of this projectile and calculate the value of theta and the u. From there, you can calculate the range and maximum height. But if you do not remember the equation of trajectory, then you can use the concept of the differentiations. You can use the concept of maximum height. It means that taking the derivative equal to 0, then calculate the value of x at which derivative is equal to 0, and then you can substitute the value of x in the original equation of trajectory to calculate the maximum height, right? And similarly, you can also calculate the angle of projection at origin. You just take the derivative and try to substitute the coordinates of the origin. At that point, you will get to know about the angle at which it has been projected, right? Let's move on to the next question here. The question is the range of a projectile when launched at an angle of 15 degree with the horizontal is 1.5 kilometers. What is the range of the projectile when launched at an angle of 45 degree to the horizontal, right? So initially this projectile was projected at an angle of 15 degree with respect to horizontal, and its range has been given as 1.5 kilometers, right? And we know that range is nothing that's equal to u square sine 2 theta over g sine 2 theta over g. It means that we do not know the value of u. Theta is 15 degrees, so it will be sine 2 theta will be 30 degree, right? That's upon 10, right? Sine 30 is 1 over 2, so it will be u square upon 20, right? That's equal to 15. That's equal to, sorry, 1.5, correct? So it means that u will have the value equal to 20 into 1.5 will be equal to 30, right? It will be equal to 30. So it means that u will be equal to yes, u will be equal to under root of 30, right? Under root of 30. U is equal to under root of 30, correct? U will be equal to under root of 30. If u is equal to under root of 30, then we have to calculate the range. That's R2 when it has been projected at an angle of 45 degrees. So that will be equal to u square. Once again, u square sine 2 times 45 degree, right? Over g. and sine 90 is 1, so it will be u square over g, correct? And u square is nothing, that's 30 over g, that's 10. It means we'll have 3 kilometers of range when it is projected at an angle of 45 degree with the horizontal, right? So let's move on to the next question. The question is with respect to the horizontal projectile now. It's with respect to the horizontal projectile, right? The question says that a projectile is fired horizontally with a speed of 98 meter per second from the top of a hill 490-meter high. Find the time taken to reach the ground. So the time taken to reach the ground will be nothing. It will be equal to under root of 2h upon g that we discussed in the previous slides. That's equal to 2 times h is the height from which it has been projected. It will be 490 upon 9.8, right? 490 upon 9.8. So 49, it will be equal to 5 nines of 40, right? 5 nines of 45, 5 eights of 40, right? So it will be 1 multiplied by 2, right? That will be equal to 2 into 50, that's 100, right? So root 100 is equal to 10 seconds. So it means that the time of flight for this projectile will be 10 seconds. It means that it will take 10 seconds for the projectile to strike the ground, right? The distance of the target from the hill, it means that we have to calculate the distance of this target from the hill. It means that if the target is here, point P is the target from this hill, from point O, then this distance we have to calculate. It means we have to calculate the range for this projectile, right? We have to calculate the range for this projectile. The range for this projectile will be nothing. It will be the horizontal speed with which it has been projected and the time of flight. So horizontal speed is 98 meter per second and time of flight is 10 seconds. It means that 980 meter will be the distance of the target from the hill, right? Finally, we have to calculate the velocity with which the projectile hit the ground. Velocity with which the projectile hit the ground, that was calculated as, it was equal to under root of u square plus g square into t square, right? So that's equal to u square, that's given as 98 whole square, right? And g square will be equal to plus g square, that's 9.8 square, right? Into 10 square, right? So that will be equal to 10 square, that's 10 square, right? We can also rewrite it as 98 ka whole square, right? It will also be 98 square, that will be equal to 98 root 2 meter per second, right? 98 root 2 meter per second, correct? So 9.8 multiplied by 10 will be 98. 9.8 multiplied by 10 will be 98. So it will be 98 square. So finally, it will be 98 root 2 meter per second is the speed with which it will strike the ground back, right? So let's try this question here. This is the question number 2 with respect to this horizontal projectile, right? A relief aeroplane is flying at of a constant height of 1960 meters, right? There is some relief plane, right? This is the plane, correct? And this plane is at a height of 1960 meters from the ground, right? And this plane is moving with a speed of, it's given as it's moving with a speed of 600 kilometers per hour, right? 600 kilometers per hour above the ground towards a point directly over a person, right? Struggling in flood water. At what angle of sight with the vertical should the at what angle of sight with the vertical should the pilot release a survival kit if it is to reach the person in water, right? So somewhere here there's a person in the water, right? There's a person in the water. Let's suppose this is the person in the water, right? And we have to drop a survival kit or relief kit for this person, right? That means that this is the line of sight, right? This is the line of sight between this aeroplane and this person. And if we drop a survival kit from here, it means that survival kit should go in this way, along this trajectory and fall exactly at this person, right? So that he can receive that survival kit, right? And let's suppose this angle of sight here, it is equal to theta, right? This is equal to theta, and this is the height and this is the range here, right? We have to calculate this angle theta. If we calculate the range of this projectile, range will be the speed multiplied the time of flight, and time of flight will be nothing, that will be equal to under root of 2h over g, right? 2h over g. So h is given as 1960 meters over 2 into 9.8, right? 2 into 9.8, right? So it will be equal to 20, right? It will be equal to 20, correct? So time of flight will be equal to 200 over 2. That will be once again equal to 10 seconds, right? So it means that it will take 10 seconds for this relief kit to strike near this person who is in the water, right? Then range of this projectile will be equal to speed which it's flying at 600 kilometer per hour. 600 kilometer per hour. We can convert it into meter per second. We'll multiply it with 5 over 80. Multiplied with the time of flight, that's 10. So it will be 6.1 over 6.3, right? So it will be 5,000 over 3, right? That's the range of this projectile, right? That's equal to range, correct? And if we have to calculate this theta here, theta will be, we can calculate this theta here as tan of theta, that's range upon this height, right? Range is nothing, range comes out to be 5,000 over 3 and divided by this height, that's 1960, right? If you calculate this, it will be approximately equal to 1.7, right? Or we can write it as root 3, right? Root 3. And we know that the value of root 3 for tan theta is equal to 60 degree. At theta is equal to 60 degree, the value of tan theta comes out to be 1.7 or root 3. So it means that he should have angle of sight equal to 60 degrees so as to reach this survival kit near the person who is stuck in the water, right? Who is stuck in the water. So that's it, how we calculate the angle of sight, right? Let's discuss the last question with respect to this horizontal projectile, right? This is the last question with respect to this horizontal projectile. A particle is projected horizontally with a speed of 20 meter per second from the top of a tower, right? After what time will the velocity of particle be at 45 degree with the initial direction of projection, right? Okay. So it means that this projectile has been projected like this from the top of this tower, right? And this is the velocity at any instant, right? This is the velocity at any later time t, right? At later time t, the velocity, okay, at later time t, the velocity of this projectile will be like this. This is the velocity of this projectile, right? This is the projectile here. And let's suppose this is the velocity of this projectile. This is vy component and this is the vx component, right? Correct. So this is the angle, right? This is the angle after some time t, that's given as 45 degree, right? This is the 45 degree. And we know that this tan of theta is nothing, that's equal to Vy over Vx, right? That's given as 45 degrees. So tan 45 will be equal to 1. That will be equal to 1. It will be equal to Vy upon Vx. It means that after this time, the Vy will be equal to Vx, right? And the horizontal component of the velocity is given as, that's given as ux equal to Vx, that's equal to 20 meter per second, right? Right? 20 meter per second. It means that Vy is equal to Vx, that's equal to 20 meter per second, right? And we know that Vy is nothing, that's equal to Vy is equal to gt, right? That's equal to gt. So that's equal to 20. But t is equal to 20 over g. The value of g is 10. Then after time t equal to 2 seconds, the angle will be 45 degree, right? So it will take 2 seconds for this projectile to have an angle of 45 degree with the horizontal, right? So that's it for today. In the next lecture, we'll be discussing more about relative speeds and the relative velocities, how we calculate the relative speeds and the relative velocities, right? That will be discussed in the next lecture, right? I hope you understood this lecture. We'll be meeting in the next class. Till then, take care and goodbye.